All right, let's take a look at the Chapter 6 homework. This is problem number 1. And in this particular problem, they want you to calculate the mean and the variance. And so again, this is your discrete probabilities. They give you X outcomes, which are finite. So you get 5, 10, 15, or 20. And then this P of X means the probability of each outcome. They give those to you. And of course, I'm going to show you the Excel file in a minute, but I'm going to show you how to calculate the mean and the variance for a discrete distribution. Now, let me page down. They show you the answer down here, but I like it better in an Excel table. It makes more sense, I think. But simply to get the mean, all you're going to do is take each individual probability and multiply it by its own probability and then add it up. So essentially what you're going to do is you're going to take 5 times 0.1, 10 times 0.3, and so forth, and you're going to add those up, and then you sum them, and that's going to give you the 14.5. Now, to get the variance, they're going to show you how you take each outcome, like 5, subtract the mean, you square it, and then you multiply by its individual probability. You do that for each one of these, and then you add those up, and then that's going to give you your, it's called your variance. And again, I'm going to show you this in a visual in a second. So let me get my Excel file up. There we go. And so again, on this particular problem, you can see the mean's 14.5. I took 5 times 0.1, there's your column, 0.5. 10 times 0.3 is 3, 15 times 0.2 is 3, and 20 times 0.4 is 8. You add those up, 14.5 happens to be your mean. Now, to get the variance, I went ahead and set up a column to do all this. So x minus xi, that's, I'm supposed to mean that is actually the mean. So what I'm doing is I'm taking 5 minus 14.5 gives me negative 9.5. 10 minus 14.5 gives me negative 4.5. 15 minus 0.5 gives me 0.5, and so forth. I did that for each one of these. I subtracted out the mean, and then I squared it. I squared each of these individual numbers. And then once I squared them, I took 90.25, and then I multiplied by 0.1, and I got 9.025. So I took each of these squareds, again, multiplied by their probabilities, and then I did that right here. You add them up. That happens to be your variance. If they had asked for the standard deviation, then you'd simply just take the square root, the positive square root of the variance. All righty, so that is it on problem 1. Let's go back. So you got that. All right, so let's check out problem number 2. Same thing, I'm going to show you an Excel file. So again, what they give us is they give us our discrete outcomes right here, 0 up to 4, and they give us the frequency up to 50. And then down here, they're showing you this is essentially your relative frequency distribution where you're converting these into probabilities. And of course, this is going to be discrete. So let me first show you, what they're asking. They want you to essentially convert it into a relative frequency table, which you've done before. And of course, this is discrete because these are finite outcomes. And then they have a couple questions on the probability of 3 or more. And then they want you to get the mean. And then this one, they do want you to do the standard deviation. Okay, so let me get to my Excel file. Let me pull this up. All right, there we go. And so as you can see, I've got, here's my number of calls, here's the frequency, and then to get the mean, I'm just going to show you the mean. I multiplied each of these, or I'm sorry, to get the relative frequency, you just take 8 divided by 50, 10 over 50, 22 over 50, 9 over 50, 1 over 50. That's my probability. So that's where those numbers are coming from. And then to get the mean, so at that point, what you do is you take x is 0, 1, 2, 3, or 4, multiply your variables times your probabilities. I did that individually, added them up, and then there's my mean. Now, to get the variance, I did it just like the other problem, x minus x bar. So 0 minus 1.7 is negative 1.7. 1 minus 1.7 is negative 0.7. 2 minus 0.7 is 0.3, and so forth. I then squared each of these. Here's my squared. And then once I got this, I took your squareds times their probabilities right here. And then this column, you add those up, you get your variance, which is 1.01. And then you just hit the square root button. The square root of your variance would be your standard deviation right there. So that's where they're going to get that. All right, now, the other questions they then ask, let me convert my mouse over, is, let's go back. So then I'm just reading from the problem. They said, what's the probability that you get 3 or more calls are made in a day? So I guess they want 3 or more. So if it's 3 or more, guys, all you got to do is go to the probability column. 3 or more would be 0.08 and 0.02. So if you wanted 3 or more, you just have to add those together, and your answer, of course, would be 0.20, and that's what you're going to get for part C. Part D was simply what the mean was, and the standard deviation, I believe I already answered. And so that's that one. So let me go back to our screen, just so you can see the final answer. So here's your answers on that probability. There's the mean, of course, there's the standard deviation. And of course, here's all the explanations again, but I think if you follow my Excel worksheet, I think it'll make more sense to you. All right, so that is what we say, that's number 2. Let's check out number 3, again, another table. So again, I'll show you the Excel table in a minute, but again, here's all your frequencies. And once again, you can see you're going to convert all these numbers into a relative frequency. That's going to be your probability. And in this case, it looks like everything's out of 250. So you'd simply take 20 divided by 250, 49 divided by 250, and so forth. And of course, that would be your probability table. I'll show you that in a minute. Of course, these are discrete, or finite outcomes. I'll show you how to get the mean and the standard deviation again. And then, of course, the average is 3.44. And then they ask a couple questions. X is either greater than or equal to 6, or X is less than or equal to 3. Those are called cumulative probabilities. And again, I'll show you in the table where I get that. So let me head on over. Let me show you my table. All right. So as you can see, let me get my stylus back on. All right. So just like before, I converted all these into your relative frequencies or your probabilities. I then, get X times your probability of X. Add those up, that's going to be your mean. And of course, you have to take the differences between your X and your mean. You put that here, you square them, and then you take the square times the probability. That's this column, add them up, that's your variance. Your standard deviation would be the square root of 2.2304. That would be that number right there. So as you kind of go back and compare the answers, this is the table. You just have to write this one out. Now, when they want the probability that X is greater than or equal to 6, so what you simply have to do is you go to your probability column, your relative frequency, and greater than or equal to 6 would be 0.052 plus 0.02 plus 0.012. So in other words, it's going to be the cumulative probability of these 3 right there, and it's going to give you about 0.084. Now, when they ask for less than or equal to 3, that's 3 or less, you have to add up these 3. So it'd be 0.08, 0.196 plus 0.3, and that's going to give you 0.576. All righty, so that would take care of this problem. Let's go back. All right, so that was problem number, 3? Let's go to problem 4. Now, in problem 4, and I'm going to show you the binomial tables in your book. And once I've shown you that, I've actually recreated this in Excel. It's real easy to do. So when I start to work these problems, I'm going to show you my Excel workout. But in case you're wondering, so again, I'm going to leave this page in a minute. So I'm going to go back to hit home. And I'm going to hit library. I'm going to hit our book. And then once I get into the book, I'm just going to cancel that. Go up here to this tab. And you want to go back to where it says Appendix B and binomial probability tables, and here's where you go. So whenever you use these tables, n is going to be the number of trials, and each one of these numbers in the bold in the upper row here represents the probability of success. That you like to use the pi symbol. So all you got to do is find n is equal to whatever your trials are, and then the top row in bold is the probability of success, which will be given to you. And then this left-hand column, that's going to be the number of successes. X is 0, 1, or whatever. They're going to give all that to you. And all you got to do is, whatever the problem is asking you, you go within these tables to find the area of probability. So you do not have to use the formula. You either use the tables, or if you want, I'll show you in Excel how I'm doing it in Excel. So again, this is your table where you're going to go. Now, on this first one, let me go back to my Excel real quick. On this first one, you're going to be looking at, I believe it's n is equal to 3 and the probability of success is going to be 0.6. So what's going to happen is in this problem, you want to find where n is equal to 3, and then there's a probability that is 0.6. And so this would be the column that you'd want to go to in this table if you're trying to find all the different outcomes for n is equal to 3 trials. You'd have 0 outcomes, 1 outcome, 2 outcome, or 3 outcomes. That's the finite outcomes. And if you had a probability of 60% occurrence, that's going to be your success rate. This would be the numbers that you would use depending on what the problem would be asking, of course. All right. Now, so I'm going to go back to our the actual problem, and let me show you what I've been doing. Let me get back there. There we go. All right, so let me get out of this page. Let's go back to our home. All right, somehow. Okay, let's stop this one. Hold on, let me just end this.